framework for diagrams and graphical views for web application. I am Miro. This is my colleague Jan. We are from TypeFox, and we are involved in several Eclipse projects and open source activities. Feel free to follow us on Twitter to get news and updates on what we're working on. So now first, what is this about? Our goal is to be able to visualize complex relationships, and that can be anything from models, dependencies between different subsystems in your application or parts of your data that you have extracted, networks between components, actors in actor-oriented systems, or anything like that, states and so on. And we all know very widespread examples that use graphical notations to convey information in a very intuitive way, like, for example, state machines and state charts, which are around for many years already, and control flow graphs, which are especially important for language design and reasoning. Then UML diagrams like activities and class diagrams that are well known, and block diagrams that are very important in embedded domains such as automotive and airspace domains and so on. So, thinking about all these kinds of applications, there is already a lot of technology and tools that are based on the Eclipse platform. So we have the graphical editing framework, an old version and also a newer version, and we have other frameworks that build on top of that, like Sirius. So now we would like to move this to a different level, different technology stack, building on things like scalable vector graphics, SVG, which are supported by all modern browsers, style sheets that are very useful to very easily fine-tune and change the style, and even be able to switch the style of your visualizations at runtime very quickly and easily. And making use of new technologies like the TypeScript language, which is a very excellent programming language that is compiled to JavaScript. And this motivation to get such a framework on these technologies is why we created Sprotty. So it is meant as a framework that you can use to build your own visualizations, your own graphical views, your diagrams, viewers or editors, but also as a basis that can be used, for example, by Sirius to build their modeling tools on top of that. So it is really meant as a new basis for next generation visualizations. I will start with a demo to show one example. We will have several examples in the course of this talk. So first thing I would like to show is something. There's a web page for this example. You can see that at npm-dependencies.com, but I will show the same thing in a different way, embedded in Theia IDE. So this example is about Theia. Yeah, if you don't know that, it's a new web-based IDE that has somehow similar concepts as Eclipse, in the sense that you can use that as a basis for rich client applications. So it is highly customizable. It is usable both in web applications and also as a desktop application using Electron to bundle it. And you can build extensions on your own, and we did this. And for this example, we built an extension that is able to visualize the dependencies of an NPM package. So if you don't know that, NPM is for the web world similar to what Maven is in some way is for the Java world. So there's a package registry, which is somehow similar to the Maven central repository. So you can get metadata and information about packages or modules. So in here I have a locally checkout project, and I can right-click the package JSON, which is like a POM XML in a Maven project, and say, please show me a dependency graph. And it loads the dependency directly from the file, and now I can step by step, resolve further dependencies, and they are either fetched from the remote registry, which has all the metadata available, or in this case, once I have properly set up the project, they can also be fetched locally from the information that is available. So I can navigate through the graph and explore the dependencies. So this is the example we use here is Angular CLI. So it's a part of the Angular user interface framework. And I can also say, resolve everything in this graph. And then we get a huge dependency graph because it's a quite big component. So now this is not very usable anymore because it's just too much information. So I have to filter down. So let's say I want to show only the packages that are part of Angular itself. So I can just start typing Angular. Probably you haven't seen that. I have a small filter box here on the top right. And now the view has been condensed down to only a few packages and their relationships. So I can, this example application is available as a standalone web page online. So, so that was this one that I have shown in the beginning. So you can just go there yourself with your laptop and try it out. It's just one example of how you can use visualization to convey information about how packages and modules depend.
All right, thank you, Miro. I want to show you a more basic introduction now into what Sprotty is and start with another demo. That's the Sprotty examples. We shipped that with Sprotty. You can actually also access this example online with this link that's on the slides. We will publish the slides afterwards. So this is how we kind of started evaluating what we really need. If you know me, maybe you've seen me on other conferences before. I'm pretty much into graphics, but I'm also pretty frustrated about the state of graphics frameworks because I think we have to think a lot more about modern usability patterns. This was kind of the prototype which we started to see whether that entire thing scales with SVG and TypeScript and so on. And you see it's pretty smooth actually. So this is 200 nodes all connected to one. And it's actually directly reacting to what I do. And what I do is I use my touchpad. You know, that should be supported by a modern framework. We also, of course, you can select things. So this is just the basic functionality you expect from a graphics framework. And we have a button here that you can scramble nodes, just put everything to another place. And what you see is a transition. This is very important to us, that we don't flicker, we don't just go from one state to the other directly, but have a transition such that we see what's going on, we as human users. And the entire thing also works for undo, redo, or travel back in time if you want so. So if I undo in this diagram, you see that it's also animated, and even the motion that I did is animated backwards. So that was one of the key points why we did this. It's stylable with SVG, and it has a lot of nice additional features. We cannot really tell you about everything, but I just wanted to show you the basic thing about it. So let's talk a little bit about the architecture. And when it comes to graphics frameworks, it seems to be set that you use a common pattern that's called the model view controller pattern. I guess all of you know that. We had a closer look at that, and I've been working with a lot of graphics frameworks using that. And I always had a problem with this pattern because it usually leads to a micro wiring of components. So a node is kind of wired to its connection, and that is wired to another node, and so on. So if an event happens, something in that graph changes, you get a lot of micro events traveling in that graph. And you often get feedback loops, such that, for example, you zoom in and it zooms in to infinity, you know? So it's hard to test, it's hard to control, and it doesn't really match the way we do things in the web. So we ditched that pattern. And we chose something that is more appropriate for web applications. And if you have ever seen React or React Flux, you may recall that cycle. So we have a single circular unidirectional flow of information. All our events just travel that cycle through 3 major components in that thing. So if you want to test anything in your Sprotty-based application, it's pretty easy because you can consider all of these components as, well, almost stateless functions, and you can test functions very easily. You cannot test huge object graphs which have a lot of state everywhere. All right. So this is how it works. We have, it all starts with the action dispatcher. The action dispatcher takes so-called actions, which describe something that's going on in the diagram on a pretty high level, like selection changes, this is the new selected node, or this is the new diagram model, the entire new model. The action dispatcher usually turns that into a command, and the command has the execution on it. These actions, they're just data structures. They can also be serialized, which will be very important later on. But the command, it has the behavior attached to it. The command is executed on the command stack. This is a very common pattern, such that you have undo and redo. And the command stack will create the new state of the diagram by applying the command to the current state. And that new state of the diagram, the S model, this is our diagram model, S stands for Sprotty, of course, is handed over to the viewer, and the viewer turns it into SVG elements. And SVG is like, if you don't know it, it's like HTML. You can actually embed it in HTML, so it's XML elements nested in each other. It's also a DOM technology. So when it comes to DOMs in web applications, you have to know that it's very expensive to deal with changes in the DOM. This is why frameworks like React and others use a pattern that's called a virtual DOM. So what they really do is they have kind of the same structure, data structure of the DOM in memory. They apply the changes to it, and then compare this virtual DOM with the real DOM and just do the minimal changes in order to have the nice interactivity. And we do the same. So once we got the S model, we traverse it. It's a tree. And for each element in the S model, we look up a view. And a view is a function that turns the model element into a SVG subgraph. That one is contributed to the virtual DOM, and then we have a patch method to actually patch the real DOM. We use a special virtual DOM framework here. It's called SnapDOM. We choose that one and not React because it's really lightning fast. And if you have a big diagram, these DOMs are really big. And you've seen the animation. It's every animation step is in fact going through that loop, the viewer loop here. So it's really fast enough for bigger things. That was the view side of things. Now let's look at the behavior. The first question that arises is, how does the initial model come into my diagram? And for that, we have another component. We call that the model source. That can be anything. It just has to create an action that says, set the model to this, and pass in the model. Why is that cool? You may not have seen that, but the title has changed of the slide. We can use Sprotty in a client-server scenario. That means instead of using a local model source, we use a diagram server, which is, in fact, a proxy on this side connecting to a WebSocket. And on the other side of the WebSocket, there's a real server serving the model that really knows about the semantics and creating the S model from that semantics. This allows us to implement this diagrams in the web where the actual content does not reside in the browser. So if people are talking about modeling tools, they often think about having the entire model pulled into the browser, which is generally not such a good idea because models tend to be large. So the model can be from a database, can be from some model storage, whatever. So the thing that you really want to visualize, it doesn't really matter where it comes from. You do it on the server, you implement that server with the Sprotty-based classes, and that server responds to get model actions and creates set model actions. This way you have a nice separation. The diagram only knows about diagram stuff, like nodes, edges, graphs, and the server knows about all the semantics. And if you've been around a bit, this might remind you of something That's coming back later. That pattern also allows us to distribute the workload for heavy computations between client and server, because these actions are just data structures, as I said, and I can decide based on each action type whether I want that to be processed on the server or on the client. And for example, there's a nice layouting framework called ELK in Eclipse. Miro is one of the main contributors. And that's written in Java, so it usually doesn't run directly on the client, and you may want to have that layout algorithm just run on the server. And there's no problem to do that, because we can say, okay, then the layout action should not be performed on the client, but on the server, and everything's done. Okay. Do you want to show that demo, or should I?
Yeah, that's for the next step. So the next demo is also one of the first examples that we have implemented based on Sprotty. Also part of the exploration phase, and I would like to use that. Where is it? To use that as an example to show a few steps that are necessary to get to a working application that is based on Sprotty. So we'll increase the web page size here. So what we see here is on the left side an text editor that is backed by Xtext. So this means it's a DSL, domain-specific language, and we have a server implemented in Java that provides code completion, for example, and other services, validation, and so on. And then we have in the middle and on the right two different visualizations that have been derived automatically from the same data source. So this is a good example that you can have kind of projections on the same data that can be very different, so different kinds of views on the same model. Yeah, I can change the model here, create new tasks, and you see once I have done that, I get automatic updates of my model. And so it's connected on with incremental automatic updates that show the minimal changes here using animations. I can still zoom in and out here. I can select nodes, and the selection is synchronized between the three different views. Yeah, and all the animations that you can see here have not been implemented specifically for these examples. They come as part of the framework. So that is really something that we decided it's so important that we want to make it as easy as possible and to have them automatically. And so everything that you see, like transitioning from one point to another, and also have the incremental updates of the model, all that comes with the Sprotty framework. So now let's take this example to go through a few basic steps that you typically have when you implement something directly based on Sprotty. So the first thing is the model, and not in the sense of your original data source, but more in the sense of the model that is handled internally by Sprotty, which just describes the structure of the diagram. And Sprotty comes with some predefined classes for that, and you can define your own classes if that doesn't fit exactly what you have. So very often used things are nodes, labels, ports, edges, all these things that you use to make a network graph or something like that. And so what you can do is to use these directly as to create your model structure, or you can create subclasses, which is very useful if you want to add your own domain-specific data that if it is important, for example, to control how the views should look like. So like, let's say if a task has can be in different states, and depending on the state, the corresponding view should be colored either red or green, then you can encode that simply by a property in this class. Now, this is the structure of our model. Modelers would maybe call it the meta model. And now let's have a look at an instance of that. So we have, in this example, 5 task nodes and 1 barrier node here in the middle, and the tasks and barriers are connected by flows. And the flow is in edge, So it's a connection. It means it has a source node and a target node. So it's symbolized here. So this is just the structure. And then at one point, as explained by Jan before, we need to transform this structure into SVG. So it's something that can be rendered by the browser. And in this example, we transform every task node into a circle, every barrier node into a rectangle. And then it might look like this, which is similar to what you have seen before. So I will also show a small example of how a view implementation might look like. Here we are using a technology called JSX, which is very popular, for example, for React development. And this version here is TSX, which is the TypeScript version of that. And it means that you can embed HTML or SVG elements directly in your source code, which is very nice because it gives you a very compact format to describe how the view elements should look like. So here we have an SVG group, that is the G element here. Then we have an SVG circle and a text. And we can set properties like radius, X and Y coordinates, and assign some CSS classes which can be used for fine-tuning the rendering in some CSS files afterwards. So that's the view. Then Sprotty offers very nice means to configure the whole application, and we use dependency injection as a concept for that. That is, that concept itself is very widespread in all kinds of domains, and also, especially in Java, there is Google Juice as one framework that is very popular, or Dart, no, the Dagger is called. It's another implementation of dependency injection. And so here we use Inversify.js. It's a JavaScript framework for that. And so we can describe dependency injection modules, and you can, so that gives you the ability to fine-tune and customize every single aspect of the Sprotty application. So every class that comes with Sprotty is configured with dependency injection, so you can just replace it with your own implementation. It's like a subclass that somehow changes the default behavior. So in this example here, it's just shortened to the main kind of configuration, which means to assign specific model classes and view classes to every kind of element in our diagram, like a flow, a task, a barrier, and so on. So, and all that is then bundled together into a dependency injection container. That is kind of the concept that is used here in this dependency injection framework. Now next, let's have a very quick look at the server side. Here we cannot say a lot generically, because the main task of the server is to transform an application model that can be anything, as Jan said, into a diagram model, which is the Sprotty format, that can be serialized into JSON and sent through a WebSocket, for example. And how this transformation looks like, so what this arrow means exactly, is very application specific. So it's your responsibility then to derive the data from your model source, and so to identify what are the elements that I want to show in my diagram, and to create those data structures. Then it's just simple data structures that can be sent to the client. Very small example for our task flow diagram that we've seen before. This is a function implemented in Extend, a very nice programming language that is built on Java, so it's transpiled to Java. So here we get a domain model class as input. So task is part of, in this case, it's part of an EMF model. And in this function, we create a task node, which is the data structure that is used by Sprotty. So here we extended the Sprotty structure with our own task node class. And we assign some properties like a type, that is the diagram element type, and an ID to identify it, and some name which will be shown in the view then. And that's it. So that's really all we need in this particular example here. Of course, in your application, it could be more involving to get the data, but it really depends. So next demo, Jan.
Okay, remember I said that we have that client-server separation, and that client only knows about graphical representation stuff, and the server knows about the actual semantics of the diagram. Does that remind you of something? Anybody? That's pretty similar to the language server protocol. Who knows what the language server protocol is? Well, quite a few. So the language server protocol has been introduced by Microsoft, just to shortly describe it, for the VS Code IDE. And the idea is that there's a JSON-based protocol between the client and the server. The client, in this case, is a text editor, which doesn't really know about the semantics of the text that's actually edited. And the server is something that is specific to the language in which this text is actually written. So whenever I do things like content assist in the text editor, the dumb client doesn't know what to do, but it asks the server, oh, look, I'm in this file, and someone wants to have content assist, what could be good proposals? And the server knows about, has parsed all the files, knows about what they mean, knows their ASTs, and can give good answers on that. And these answers are transferred back, so the client can render the content assist. And the same separation works with Sprotty. And we designed it that way, of course, such that we can enhance language servers with graphical capabilities and use a very thin Sprotty client on the client side next to the text editors, and an enhanced language server also speaking a little bit of the Sprotty protocol on the server side. And this is what I want to demo. So this is once again Theia, the online IDE, and the language that you see here is Yang. I'm not sure, does anybody know Yang? No? Okay, this is a network language, and in this case we enhanced Yang with diagrams. So you see this is a xtext-based editor. You have all the things like content assist and hoppers and the like, which you expect from xtext, and it's backed by a language server. So xtext can be used to generate a language server. If you didn't know that, keep that in mind. And this language server has been enhanced with Sprotty capabilities, such that when I say, oh, show me this in a diagram, open this as a diagram, it renders a diagram for me. Okay. It's always too little screen real estate, so I that way. Okay, and that one is synchronized. So for this identity, I have a node for this identity. I have a node for this list. I have a node. You see, whenever I click in the diagram on something, the respective section gets selected in the editor, and it works the other way around too. So when I make my way through the text, the diagram scrolls to the right to the respective parts, if they have a representation. Almost all have. Let me show you that this is really synchronized. So we are going to this place here. There is this NACM group, and I just add another identity. So I use content assist, call it new, and it needs, as far as I know, it needs a base in order to be connected to the NACM group. You see it's already appeared, but it needs to be connected to the right base group. And when I fix the syntax error, it gets sorted here. So here we go with the new node. I didn't even save, all right? This is because Theia does it automatically, but it would have worked also on a dirty diagram. Okay, this is an example on how to do that. Let's have a look how that works in architecture-wise. So this is the server side of it. Here on the right-hand side, you see the JSON RPC transferred via a WebSocket in the Theia case. And this is how you implement a language server. So you could use xtext for your language and then generate the language server for you. And the language server consists of two services: the text document service that can directly serve the editor, and the workspace service that knows about the workspace and file changes and the like. Language server protocol can be extended, and this is exactly what we did. We built a diagram language server extension, offer a diagram service, an additional one, and that adds a few JSON RPC methods to the protocol. And that works nicely in this scenario. The funny thing about the key point about the language server protocol that in theory is that it in theory allows us to use every language in every language server aware IDE. And there is not only Theia as a language server aware IDE, there's also of course VS Code, the original one, but there's also language server support in Eclipse. So let me show you the same language server enhanced with graphics capabilities in Eclipse. When does it come? Here we go. So Eclipse is of course always too small. I open a file and then make the file bigger. This is the more interesting part. Okay. So this is LSP4E is a project that integrates the language server protocol into Eclipse. This is the same language. This is actually the same example. I can now click on a button here and it opens a Sprotty diagram. Now wait, Sprotty, isn't that a web technology? Yes, it is. So what actually is shown here is the SWT browser widget. And inside that browser widget, we render the SVG of the Sprotty diagram. And it should have the same, if it works, yeah, it works, cool. The same navigation features. So I haven't shown that before. You can also expand nodes and collapse them again. And it has the same synchronization effects, and I just leave that out. But this is nice. So if you ever have to implement tooling for a certain language, really consider using the language server, implementing a language server, because that will give you support for a lot of IDEs for free. Okay. This is, I don't talk about this. Okay. Do you want to say that?
Yeah. As a final thing, we are really happy to announce that there is an Eclipse project proposal for Sprotty. So it's currently in public review, so you can go there and have a look at what we described as the scope of the project, and also, very importantly, what is not in the scope of the project. And you can go there and comment on Bugzilla and get in contact with us, discuss with us how that could help for your project, and what kind of use cases you have in mind that might help also to further fine-tune and specify the scope and the description of this project. So it's really starting now to get into the, to become a part of the Eclipse community of open source projects. And so now I would like to finish with a small roadmap, so ideas and things that we see ahead for Sprotty that we would like to implement in the near future. So first thing, of course, to set up the Eclipse project and all the connected resources, like the repository that it is then under the Eclipse namespace and everything like mailing list and so on. Then we would like to implement more editing features. A lot of the examples that we have implemented so far are read-only views, which is a very important kind of application in our view that already is useful in many cases, in many kind of environments. But of course, there are cases where you want different kinds of editing capabilities. And we would like to explore also user experience-wise in this area, how to provide very new concepts and also old good concepts and to implement them as part of Sprotty. Then we would like to offer even more means to navigate and explore your models. As some of you may know, FX Diagram, a project that was implemented by Jan several years ago based on JavaFX. And there he had very good and very interesting ideas on how you could explore data with different concepts that are very different from what you know from traditional Eclipse-based frameworks like GAF or GMF or so. Then we would like to document and more precisely specify the client-server protocol that is part of Sprotty. So put that into some, maybe even in a separate repository. That goes a little bit into the direction of what we have heard also from Melanie's talk about talking about the diagram server protocol. So we would like to also to get more in discussion on that. And we would like to add more layers on top of the Sprotty basis so that it makes it even faster for you to implement certain use cases. So that we consider that as kind of a library that you can use together with Sprotty that offers some very common things. I don't know, like a palette or certain kinds of actions that you can features that you can implement more easily then. So that's it for now. We have no time for questions. Maybe one or so. Is there any question? Yeah.